Hi students, welcome to Sangal Planning classes. In this session, we'll be dealing with 5 mark questions of chapter differential equation. So we have already completed 1 mark and 2 mark sessions of this chapter. So in total, you will get 8 mark questions from this chapter. So basically in the 5 mark session, they'll ask questions about the solution, finding the solution of a first order linear differential equation. Okay, I hope everybody is familiar with the standard form of first order linear differential equation. It is nothing but dy by dx plus some p into some p into x is equal to q, right? Some p into y is equal to some q, isn't it? So I'll write it once again here. So we can write the standard form here, that is dy by dx, right? dy by dx plus p into some y, right? Some y equal to py equal to q, right? This is a standard form of a linear differential equation, right? And what is this P and what is this Q? What is P and Q? P and Q are either constants. P and Q are either constants or functions in X only, right? Either it will be functions of X only or it will be constants. So that is P and Q, right? These type of equations, how will you solve these type of equation? We'll find out the integrating factor. What is integrating factor? Integrating factor is equal to e raised to integral p dx. E raised to integral p dx, right? And then how will you solve this differential equation? That is y into integrating factor is equal to integral of q into integrating factor dx plus c. This is how you solve these type of equation. And there is one more form for this, that is if you are given, if the linear differential equation is of the form some dx by dy, okay, dx by dy plus some p into x, okay. The previous one was dy by, it was a dy by dx plus py equal to q, and this form is dx by dy plus px is equal to q, where this P and Q, where this P and Q are either constants, either this can be constants or it can be functions in y only, right? The previous one was functions in x only. Here, since it is x and here dx by dy, this P and Q are either constants or functions in y only, right? Then how will you solve these type of problem? We have to find out the integrating factor here, e raised to integral p, and p is a function in y, right? P is a function in y. So how will you integrate with respect to y, right? So integral p dy. The previous case was integral p dx because p was a function in x. Here p is a function in y. So how will you integrate? Integral p dy. Okay. Now what will be the solution? The previous one was y into integrating factor equal to integral of q into integrating factor into dx, right? This is x into integrating factor. Okay, x into integrating factor is equal to integral of q into integrating factor into dy. Here q and integrating factor we are integrating with respect to y, so it will be a function y, and q is also a function, it should be a function y, right? So we have to integrate it with respect to dy, right? Plus c. This is how you solve this type of first order linear differential equation. All right. So we'll be doing some problems related to this. Mostly in this session, they'll ask you to find out the solution of linear differential equation, and maybe a variable separable form can also be asked. Finding out the solution of a differential equation using variable separable form can also be asked, but mostly in the question papers and all you can see this part, that is solving a linear differential equation. first order linear differential equation of this form. Okay. And there is one more section, one more chance for questions to be asked in 5 mark session, that is of homogeneous, solving a homogeneous differential equation. Solving a homogeneous differential equation. You have to practice more problems in this session, that is I have explained now. And you should also practice questions from homogeneous session also. All right, few questions we will do it in this session. Then you will understand the concept. Okay, how you can solve these questions. All right. So the first question is, find the general solution of the differential equation dy by dx. I'll write it in the next line. dy by dx plus sec x into y equal to tan x. You have to find out the general solution of this particular differential equation. Alright, so here when you compare it with the standard form, what is the standard form? It is starting with dy by dx. dy by dx is equal to p into, p is a function in x. P is a function in x. So it will be y, right? Py equal to q. Okay, comparing it with this, we can say that P is equal to, here in this question, P is equal to sec x and Q is equal to tan x. Q is equal to tan x. Now what you have to do? You have to find out the integrating factor, that is e raised to integral P dx. That is e raised to integral sec x dx. Integral sec x dx. What is integral sec x? What is integral sec x? It is sec x. It is sec x plus tan x. Right. Log mode sec x plus tan x. It is log mode e raised log mode sec x plus tan x. Right. E raised log mode sec x plus tan x. Right. And if you apply the property, this the answer is sec x plus, the answer is sec x plus tan x. Sec x plus tan x. So we have got the integrating factor, right? Now what is the next step? We have got the integrating factor. Now the next step is y into integrating factor is equal to integral of q into integrating factor into dx, right? Plus c. Okay, so here y into integrating factor, we have got it as sec x plus tan x. Sec x plus tan x equal to integral of, what is q? Q is tan x, right? Tan x into sec x plus tan x into dx plus c, right? So we'll solve this one integral, right? Tan x into sec x, that is either you can write tan x sec x or you can write sec x tan x. Sec x tan x, then plus tan x into tan x is tan square x into dx plus c. Here we know this one's integral, but we don't know this one's integral. So first we can split it. Sec x tan x dx plus integral tan square x dx. And how can you write this tan square x? Sec x tan x dx plus integral sec square x minus 1 dx, right? So this is equal to integral, what is integral sec x tan x? What is integral sec x tan x? It is sec x, right? Plus what is integral of sec square x? Sec square x is tan x, right? Minus what is integral of 1 with respect to x? It is x plus c. So this is y into sec x plus tan x equal to sec x plus tan x minus x plus c. So what is the solution of the given differential equation? It is y into sec x plus tan x equal to sec x plus tan x minus x plus c. Minus x plus c. Alright. Now the second question is find general solution of the differential equation x dy by dx plus 2y equal to x square into log x. So this is our differential equation. This is our differential equation. All right. So how can you make it into the standard form? Here you can see that there is an x extra with dy by dx. So we know only the standard form of the form dy by dx plus some p into y equal to q, or we know dx by dy plus some p into x is equal to q. So this is an extra x is there. So first we have to divide throughout by x. Okay. That is for eliminating this x. So x by x will become 1. So first term will become dy by dx plus 2 by x y, 2 by x y equal to x square log x by x. So this is actually dy by dx plus 2 by x into y equal to x log x. It is equal to x log x. So what is p and q from this? What is p and q from this? P is equal to 2 by x and q is equal to x into log x, and q is equal to x into log x. All right. Now, what about the integrating factor? What about the integrating factor? Okay, what is the integrating factor? It is e raised to integral p dx, e raised to integral p dx, right? So this is e raised to integral 2 by x dx. Since 2 is a constant, we can take it outside. So 1 by x dx. So what is e raised to 2 log mod x, right? Log mod x. And here we can apply the property of log. So we can take this square to this side, right? Log x square. We can write it like this. So this one is equal to actually x square. So what is our integrating factor? Our integrating factor is nothing but x square. So we know how to find the solution. Y into integrating factor is equal to integral of q into integrating factor into dx plus c. So y into x square is equal to integral. What is our q? What is our q? Q is x log x into x square. X log x into x square dx plus c. Okay, just a minute. So this is equal to, how can you write this one? This is equal to integral x cube into log x dx plus c. Now, first we can find this integral, okay, because it's the product of two functions, right? So we have to apply that integration by parts method, right? So here we can consider that part integral x cube log x dx. So before proceeding integration by parts method, first we have to check that whether this is following the ILATE rule. Isn't it ILATE rule? What is it? I means inverse trigonometric function, L is logarithmic function, A is algebraic function, T is trigonometric function, and E is exponential function. So first priority for inverse, then log, then algebra, then trigonometry, then only comes exponential function. So here x cube is an algebraic function and log x is a log function. So is this following the order? First log x is preference, then only algebraic function gets the preference. So we have to rearrange this one as log x into x cube dx. Now we can apply integration by parts method. What is it? Integral log x into x cube dx is equal to first function into integral of second function minus integral of derivative of first function into integral of second function. So this is how you find out, right? So log x into x raised to 4 by 4 minus integral derivative of log x is 1 by x into integral of x cube is x raised to 4 by 4 into dx. So this is actually log x into x raised to 4 by 4 minus x 1x gets cancelled, right? So minus integral x cube by 4 dx. Okay, so 1 by 4 we can take it outside, right? Here also we can write this one as 1 by 4 x raised to 4 into log x minus 1 by 4 integral x cube dx. So this one will be like this, and minus 1 by 4 into x raised to 4 by 4, right? Plus c, okay, plus c. So we can rearrange this as we can either you can rearrange or you can write it as such itself. So for, we have got in the earlier step that y into x square, y into x square is equal to integral x cube into log x dx plus c. This was our result, and we were finding the value of this one, this integral, right? And now we have got it, so we can write is equal to log x into x raised to 4 by 4 minus 1 by 4 x raised to 4 by 4 plus c. So you can write this one as 1 by 4 can be taken outside. So it is log x into x power 4 minus x power 4 by 4 plus c. So this is our solution of the differential equation. Okay, I hope this question was clear to you all. Now we'll do a question of the form dx by dy. Okay, dx by dy plus p into x. P is a function in y, right? So p into x plus q is equal to q. All right, we'll do a problem of that type also. So the third question is find the general solution, find the general solution of the differential equation y dx plus x minus y e raised to y into dy equal to 0. So this is y dx plus x minus y into e raised to y into dy equal to 0. So therefore y dx equal to minus of x minus y e raised to y into dy. E raised to y into dy. So this can be written as we have to convert this into this form, right? This can be written as minus of x plus y e raised to y dy or y e raised to y minus x dy. All right. Now we can place this dx here itself. This is y dx, right? So dx I'm placing it there itself. So this is, and dy I'm taking to this side. Okay, dy. So this is y e raised to y minus x by y. Y e raised to y dx by dy is equal to y e raised to y minus y e raised to y minus x by y. Okay, so that is y e raised to y by y minus x by y. So y and y gets cancelled. So it is e raised to y minus x by y. So this is dx by dy. Dx by dy equal to e raised to y minus x by y. Now after rearranging this, we'll get dx by dy plus x by y equal to e raised to y. Right. Now this is of the form dx by dy plus some p into, this is actually p is a function in y, right? So p into x equal to q. Okay. So it is of the form, these are same, right? This is of the form, this one, right? Now here p is equal to 1 by y and q is equal to e raised to y. P is equal to 1 by y and q is equal to e raised to y. Okay. So we need the integrating factor, that is equal to e raised to integral p d p dy, right? Since p is a function in y, we have to integrate it with respect to y. So it is p dy. So this is equal to e raised integral. P was 1 by y dy. 1 by y dy. So what is the integral of 1 by y? Log y. Log y. And e raised to log y equal to y. Is that clear? We have got the integrating factor. And now what is the solution? That is x into integrating factor is equal to integral of q into integrating factor into dy plus c. Right? This is our solution. Right? So x into integrating factor is equal to what is q? What is q? Q we have got it as e raised to y into what is the integrating factor? Integrating factor is y dy, right? So this can be rearranged. It's a product of two functions. So we know exponential function should come last. So the order should be rearranged. So it is y into e raised to y dy. Y into e raised to y dy. So we'll find that solution. Okay. That is integral. I'm sorry, not integral. We have to apply the parts rule, right? We'll write it once again. That is the last step was y into e raised to y dy. Okay, now we are going to apply the integration by part method. So this is y into first into integral of second minus integral of derivative of first into integral of second dy. Right? So this is equal to 5 into y into e raised to y minus what is derivative of x with respect to, I'm sorry, this is actually functional e raised to y. Actually, this is, we are integrating it with respect to y, right? So it is e raised to y dy, and this is d by dy of y and e raised to y dy. Okay. So y into, so e raised to y with respect to y is e raised to y minus d by dy of y is 1 into e raised to y integral is e raised to y itself. So this is y into e raised to y minus what is the integral of e raised to y? E raised to y itself plus c. Okay. So this is x into y. Okay. X into y equal to y into e raised to y minus e raised to y plus c. Y into e raised to y minus e raised to y plus c. Okay, now the next differential equation is, the fourth differential equation is y dx plus x minus y square into dy equal to 0. X minus y square into dy equal to 0. So y dx is equal to minus of x minus y square into dy. Minus of x minus y square into dy. Isn't it? So this can be written as y square minus x dy, y square minus x dy. So what is dx by dy? Dx by dy equal to y square minus x by y. So that is y minus x by y. Isn't it? Y minus x by y. And if you rearrange this you will get dx by dy plus x by y equal to y. Plus x by y equal to y. Alright. And if you compare it with the equation dx by dy plus p into x equal to q, you get what was our previous step? Dx by dy plus x by y equal to y. Okay, so if you compare these two, then you will get p equal to 1 by y and q equal to y. Okay, now what is the next step? We have to find out integrating factor. It is integral p dy, right? E raised to integral 1 by y dy. And what is it? E raised to log y. E raised to log y means nothing but y itself. So we have got the integrating factor. Now what is the solution? It is x into, okay, x into integrating factor is equal to integral of q into integrating factor, and with respect to y, right? So just dy plus c. So this is our solution. So integrating factor is y. So integral q. What was our q? Q is equal to y. Okay, y into integrating factor is y into dy. So this is xy equal to integral y square dy. That is y cube by 3 plus c. So xy equal to y cube by 3 plus c. Xy equal to y cube by 3 plus c. Okay, so this is the solution of that particular differential equation. All right, now moving on to our fifth question. That is, we'll do two problems from the homogeneous, so that is finding solutions from of a homogeneous differential equations also. Okay. So in finding a solution for a homogeneous differential equation of the form dy by dx, dy by dx is equal to some f of xy. Okay, then we will make the substitution. We'll make the substitution y equal to vx. We put y equal to vx. So from this you get dy by dx is equal to v plus x into dv by dx. Okay, just differentiate this one with respect to x, then you will get this one. Dy by dx is equal to v plus x into dv by dx. Right. Now, if the homogeneous differential equation is of the form dx by dy is equal to some f of xy, then we make the substitution x equal to vy, then what will be dx by dy? Differentiate this one with respect to y, applying product rule we get, it is v plus y into dv by dy. This v plus y into dv by dy. Okay, so sometimes they'll ask questions in 1 mark session. There will be one question that is asked, that is if you are getting a homogeneous differential equation of the form dy by dx is equal to some f of xy, then what is a substitution that you will give? It is y equal to x. And the second one also, if you are giving a homogeneous differential equation of the form dx by dy equal to f of xy, then what is the substitution that you have to put? Then that is x is equal to vy. Okay, that thing you have to learn by heart. All right. Now we'll do some problems related to this. Show that the differential equation dy by dx equal to x plus y by x is homogeneous. It is homogeneous, and solve it. And what do you mean by a homogeneous differential equation? It is the function f of xy is homogeneous if it is a homogeneous function of degree 0. It should be a homogeneous function, and the second condition is that degree 0. What does that mean? F of lambda x comma lambda y should be equal to f of xy. Okay, f of lambda x comma lambda y should be equal to f of xy. That's why it is called a homogeneous function of degree 0. Okay, let's check whether here f of xy is this one. Okay, so this is f of xy is equal to x plus y by x, x plus y by x. All right, and what is f of lambda x comma lambda y? Lambda x comma lambda y is equal to lambda x plus lambda y by x is lambda x. So this is lambda into x plus y by lambda x. So lambda and lambda gets cancelled. That is x plus y by x. X plus y by x. So what is this? This is f of x comma y. This is f comma xy. F of x comma, that is f of lambda x comma lambda y is equal to f of x comma y. F of x comma y. Okay, so it is a homogeneous function. It is a homogeneous function of degree equal to 0. Of degree equal to 0. Okay, now what you have to do, since it is of the form dy by dx equal to f of xy, what is the substitution that you have to put here? It is nothing but y equal to vx, right? And put y equal to vx. From that, dy by dx is equal to v plus x into dv by dx, right? Applying the product rule, you will get it like this, right? So here, dy by dx is equal to x plus y by x, isn't it? So dy, instead of dy by dx, v plus x into dv by dx equal to x plus what is y? What is y? Y is vx, right? Y is vx by x. So that is x into 1 plus v by x, isn't it? 1 plus x into 1 plus v by x, right? So 1, x and x gets cancelled, right? So this is equal to x dv by dx equal to 1 plus v minus v, which means it is equal to 1, right? So what is it? x dv by dx is equal to 1. So that is dv by dx equal to 1 by x, isn't it? Now if you take a variable, apply variable separable form, dv is equal to 1 by x dx, then you can find the solution, right? So this is integral dv equal to integral 1 by x dx. What is integral dv? It is v, right? And what is integral 1 by x with respect to x log mod x plus c. And we have put y equal to vx. So from this v is equal to y by x. Okay. So we can make this one as y by x equal to log mod x plus c. And if you multiply this y equal to y by x is equal to log mod x plus c, right? So y equal to x log mod x plus cx, x log mod x plus cx. Okay, so this is our solution of the given homogeneous differential equation. All right, we'll do one more problem from this session. Okay, this is the last problem of our session. All right, so you have to practice more problems. There are different questions related to each topic in your NCRT, in your textbook. So you have to practice each of those problems. All right. Then the next question is, show that differential equation x square minus y square into dx plus 2xy into dy equal to 0 is homogeneous. It is homogeneous. And solve it. Homogeneous and solve it. All right. So this is x square minus y square into dx plus 2xy dy equal to 0. Right. So what is 2xy dy? That is equal to minus of x square minus y square into dx. Right. So this can be written as minus x square plus y square into dx, or y square minus x square into dx. All right. Now what I'm going to do is that I'm going to take this dx to the side. dy by dx 2xy dy. Right. dy by dx is equal to y square minus x square by 2 into xy. Y square minus x square by 2 into xy. Now we have got the differential equation of the form dy by dx is equal to some f of xy, right? Some f of xy, that is a function in x and y. This is a function in x and y, right? So this is of the form dy by dx is equal to f of xy. F of xy means a function in x and y. Here you can see that it's a function in x and y. So what is f of xy here? F of xy is equal to y square minus x square by 2xy, right? Y square minus x square by 2xy, right? So how will you solve this type of equation? How will you solve it? You have to put y equal to vx, and dy by dx will be, then dy by dx will be v plus x into dv by dx. V plus x into dv by dx, right? So here v plus, we'll write it in the next page, okay? V plus x into dv by dx equal to, what was our function? Y square minus x square by 2 into x into y. So in place of y you put vx the whole square minus x square divided by 2x into vx, right? So this is v square x square minus x square by 2x square into v. So here you can take x square outside, x square into v square minus 1 by 2x square into v, right? X square and x square gets cancelled. So this is equal to v square minus 1 by 2v. V square minus 1 by 2v. All right. And v plus x into dv by dx is equal to v square minus 1 by 2v. Now, what is x into dv by dx? That is equal to v square minus 1 by 2v minus v. You do the cross multiplication. So, v square minus 1 minus 2v square by 2v. So, this is equal to minus v square minus 1 by 2v. Alright, so what is x dv by dx? That is equal to minus of v square plus 1 by 2v. Now group the v and v terms together and x terms together. Okay, so this is equal to, we'll get dv and you take 2v to this side. So 2v dv divided by v square plus 1, right? Divided by v square plus 1, and there is a minus here, and x by dx, it will become uh, minus dx by x, right? X by dx, into taking to the other side, it become minus dx by x. Now it is of the form variable separable. It is separable, right? Since we are able to separate v terms and x terms together, right? So now integrate both sides to v by v square plus 1 dv is equal to integral of minus dx by x, right? And here you can see that this is of the form, first one is of the form integral of f dash of x by f of x. So this is log mod f of x, right? Here you can see that f of v is v square plus 1. What is f dash of v? F dash of v is 2v dv, right? Okay, 2v. Okay, so this one is actually it is of the form f dash of x by f of x. So we can write the answer as log mod v square plus 1 equal to minus log mod x plus c. Log, let's put it log c. In order to apply a property, we are making it as log c. Okay, so I'm taking this minus log x to the left side. So this is log v square plus 1 plus log mod x equal to log c. Okay, so this is actually log mod. What is v? V is y by x. Y by x the whole square plus 1 plus log mod x equal to log c. Now log a plus log b is log ab, right? So this can be written as log of y square by x square plus 1 into x, right? Into x equal to log c. And if you take exponential on both sides, this will be y square by x square plus 1 into x equal to c. So this is y square plus x square by x square into x equal to c. Okay, so x and this x gets cancelled. So this is y square plus x square by x equal to c. That is y square by x plus x square by x equal to c. So y square by x is plus x equal to c. Okay, or you can take this x common, right? So we can write this one as the solution as x is common, right? So this one can be written as y square plus x square by x is equal to c. So which means y square plus x square is equal to c into x. So we can write this one like this. So this is the solution of that particular differential equation. All right, so we have discussed some of the problems from finding the solution of a first order linear differential equation as well as a homogeneous differential equation. And while solving a homogeneous differential equation, we have come across the finding the solution of a solution using variable separable form method also. Okay. So we have, I think we have covered most of the important points and important problems, the types of problems that are asked for exams in within these three sessions, that is 1 mark, 2 marks, and 5 mark session. So I hope this session, all these sessions of chapter was useful to you all. Thank you.